Imaginative impresarios of the image view. I'm Professor John Gallagher, and we are going to continue to work with images in SwiftUI. This time we'll write code to flip through all of the images in your app so your users flip out. But even more importantly, this lesson is about types in Swift. We'll learn about Swift's strict typing, declaring types, type conversion, and how to overcome basic type errors. We've got a lot on deck, so let's learn big.
If you're new here, welcome. You might want to check out the course playlist to see how we got here.
Now at the end of our last lesson, we added images named image 0 through image 9, but we only took advantage of image 0 and image 1 in our last app.
When we click our button,
we flip between image 0 and image 1. But this is where we'll be at the end of this lesson. We'll be able to flip through all of our images 0 through 9, and when we get to that 9th image, we'll reset and begin showing the images starting at image 0. And before we start writing code, since we want to cycle through all of our images, I no longer need this line that sets the image name using the ternary operator, so I'm going to comment that out. Then I'll press return a couple times just to give myself some space to work before the closing curly in the button action. So let's think about the logic to accomplish this. And when you're learning to code, it's useful to think about the steps you perform in English and then translate them to code. Well, what we want to do is first start out with a blank image, which is what we've got, but then we want to make sure that the first image displayed is image 0. Then when the button is clicked, we should display the correct image, then increase the image number by 1. And if the image number is greater than 9, we should restart from image 0. And as we think about translating this into Swift, we realize, hey, we've got to keep track of our image number, 0 through 9. So let's do this in a state variable that we'll call image number. And it's got to be a state variable because we want to keep that value aside and we don't want to throw it out even as we update the screen and reset all of our views.
And before we address the image number, I'd like to change the button title to Show Message instead of Press Me.
So let's head to the top of our code, and we're going to create a new state variable, but we'll work with numbers instead of strings here. So let's call this image number. So we'll write @state private var image number, lower camel case, and at the end of this, instead of it making equal to a string in double quotes, when we're making something equal to a number, we just write the number after the equal sign like this, equals 0. Now here's something important to know about Swift. Variables are created to hold only a given type of data, and in our declaration and initialization statements up top, the type of variable is determined by the data we use to initialize the variable.
Message and image name are both initialized with strings.
See the double quote values? So these variables are said to be of data type string, and they can only hold strings. You can never put a non-string value like a number inside of them. And if you ever wonder, hey, what type of value is this? You can always option click on the value's name, and Xcode will show you the type.
So here we see after option clicking on message, the colon after message says this is a variable of type string.
Image name is a string too. So what about image number? Ooh, it says it's an int. Int is an integer data type, and that can only hold numbers, and specifically numbers without decimal points. And in your code, if you even try to replace this number with a number with decimal points, Swift will complain and give you an error. And we'll look at that more in just a bit. But since image number is a number, we can perform math on it. The math we want to perform is add 1 to image number each time we click the button and display the image. So let's head down into our button action again. So to add 1 to the image number, all we need to do is write image number. And check this out, code completion knows about image number, and if we arrow down to select it, it knows image number is of data type int. So let's select that, and we'll set image number equal to image number plus 1. And by the way, you should also know there's another way to write this.
I'll comment out the line I just wrote and head to the next line.
Image number plus equals 1. So the plus equal adds whatever on the right side of the plus equal to whatever's on the left side. And also, there's a minus equal, a star equal for multiply, and a slash equal for division. You'll see plus equal a lot in code examples, so definitely know this. Now, oftentimes when I'm writing code, I like to check the behavior each time I make a change, just to make sure everything's working like I expect it to before I write my next bit of code. So let's first make sure that 1 is being added to image number every time we click the button. And if we want to see the image number, we can use the print statement. Remember we used the print statement in Playgrounds?
We can also use the print statement in our project, but there's an important thing to remember.
Print doesn't show in our final app. It'll only show in a console area. And even though we haven't seen it yet, Xcode Projects actually has a console area too. First, to add the print command, we just enter print, and in parentheses, image number. And notice if I run in preview, I'm not seeing anything when I click on the button. By the way, the console is down here in an area known as the debug area, and you can access this by clicking on this button in the lower right-hand corner.
And when this pops up, hey, we can see in this console area here that we have a number for each time we click the button. I clicked it 4 times, so I've got 1 through 4. Now this whole area is the debug pane, and it's divided into 2 areas. The left-hand side is the variables view, and the right-hand side is the console. Now these 2 sides of the debug pane can be toggled to hide or show by clicking on these 2 icons in the lower right. When I click the icon on the left, I hide the variables view, the icon turns gray, Click it again, the variables view shows, the icon turns blue. Also make sure that the console is showing. That's where we see our print results. Now this variables view on the left can be used to show the contents of variables and other data structures.
This is super useful when debugging, but we're going to ignore it for now. We'll cover it in a future lesson. Also know there's a dividing line between these two panes, and if you click and drag, you can change the width of each pane.
Now if you want to clear what's in the console, click in the console and type Command K. But no, this doesn't restart our code, so if I click the show message button again, the last number that was showing up here was 4, now it shows 5. But if I click the live preview button, my code restarts, and I can click 1, 2, 3. You see the numbers going up again.
Let's keep clicking, and all right, we see 2, 3, 4, 5, 6, 7, 8, 9, and we go to 10, 11, 12, 13. We don't want that. When we hit 9, we want to go back to 1. How can we fix it? Let's call on our friend the if statement.
Also know that if you feel like you're running out of room, you can just click on the dividing line at the debug pane and pull that up to adjust the pane size. Now I'll click on the far right of the dividing line to hide the debug pane.
Now before we enter an if statement, we're also going to want to update the image name, and we do that just before we increment the image number by 1. Now I don't want to do that now, so I'm going to enter a comment. When I do this, I want to introduce you to annotated comments in the Xcode jump bar. So I'm going to enter a comment this way with 2 slashes and then the keyword to do,
one word, all uppercase, followed by a colon and a space.
Now notice, as soon as I do that, the comment gets bold, and I can write my comment after the colon. In this case, I'll say update the image name variable. Now to do is actually a special comment annotation in Xcode, and there are other annotations too. The all caps word fix me and the all caps word mark will also show up prominently, and these are useful because they can help you quickly spot things that are important and might need updating. Now if you consistently use the word to do in your Xcode projects, then you can use Xcode's find feature. Like most apps, you can bring up the find command with Command F.
The find area appears at the top of the code editor,
and you can search for a phrase like to do and find it. But there's also a jump bar in Xcode, which we haven't used yet, but it's pretty useful. And it's at the end of what's sometimes referred to as the breadcrumb trail, just under the toolbar. See how this shows where we are in our project icon, you are awesome, then folder, you are awesome. Then the little Swift shows the file that we're in, which is content view, and the last item in the breadcrumb trail will be different depending on where we've clicked in our code. So currently it shows my comment, but if I click above this, it shows body. That indicates that the cursor is currently in the body portion of my code. But we can click and pull down the last item in the breadcrumb trail, and we see a list of parts in our code. Now the P next to some of these items stands for property, which could be variables or constants. And if you want to jump to one of these areas in your code quickly, say you want to go where the image number was defined, you could select this and your code will automatically scroll to that part. Now I mention this not only because the jump bar can be useful as you write more code, but also notice the icon in my pull-down menu that looks like a little indented clipboard. That's my to-do comment. So the to-do and other annotations get a call out like this in the jump bar. So the jump bar provides another easy way to look at a file and easily see if there are any lingering to-do comments that you need to pay attention to.
And if I select this to-do comment from the jump bar, I immediately jump to that to-do comment in my code.
So again, comment annotations in Xcode are /to-do, fix me, and mark. And in fact, you can make them stand out even more prominently by surrounding the comment with dashes like this. See how when I pull down the jump bar, the to-do comment now has lines around it? Handy. So now let's add that if statement, and we want to put it just below where we add one number to our image number. And we'll see if image number greater than 9, open and close curlies, image number equals 0.
And I'll open up the debug pane so that I can see the console, and I'll Command K in the console to clear out the print statements that were there already.
Let's click our button. 1, 2, 3, 4, 5, 6, 7, 8, 9. Moment of truth. Click again, and we're back to 0. Nice! I'm also going to hide the debug pane since I don't need that anymore. And let's update this to-do item. Now you might be tempted to just write something like this. So before we add a number, since we start with image number 0 and we want to display that, you might want to enter image name equals and then the string literal image plus image number, right? Looks good, but Xcode gives us an error. And if you click on the little red error circle, it says cannot convert value of type int to expected argument type string. Oh yeah,
Image name and this image literal are both strings,
but image number is an int, and we learned that in Swift we can't combine values that are of different types. And so to explore this concept a little bit more, it's going to be useful to jump into a playground. So let's do that now with File menu, New, Playground. Select blank. I'm going to name this Types Playground. I'll resize the playground window and we'll return to the playground in a bit, but as I show you some concepts on the slides, you're welcome to type some of those things into the playground to try them out. Now let's take a look at the most common Swift data types. Now we've already been working with strings, and just about anything you can put between double quotes will be considered a string, including emojis. We've seen double quotes with nothing in the middle is also a string. That's called the empty string. That's a string with length 0. And a number between double quotes is also a string. But try to assign a number directly to a string without double quotes, and that's not allowed. You'll get an error. Now we've also talked about the Boolean data type. That type is the Bool type in Swift. And those values can be either true or false, nothing else. And true or false also has to be in lowercase. Capitalize true or false, and that'll cause an error. And try to assign the word true or false in between quotes to a value that's already been declared as a bool, and that'll give an error too, because false with quotes is a string, not a bool. Now in this lesson, we've introduced the integer data type, or int. And ints are whole numbers. They can be negative values or 0, but they can't have decimal points. Now there's some other rules for ints too. They can't have commas in them, no currency symbols, and no % characters. So the number 5, that's an int. 0, that's an int. The larger number 1, 2, 3, 4, 5, 6, 7, 8, all ints. But a 5 in quotes, that's a string, not an int. Any number with commas is going to generate an error. You can't have commas in numbers in Swift, and that's because commas have a special role in the programming language. And we've already seen that. Commas are used to separate different values in a function call. So if you had commas in an integer, that would be considered 2 different values. Also, percentage signs at the end, no good. That'll get an error. Again, no $sign or other currency symbols. And once a value has been defined as an int, you'll get an error if you try to set it equal to a value with a decimal. And there are a lot more data types, but the last major data type we'll introduce is the double. Now doubles have decimal values. They can be positive or negative, and also like ints, no commas, currency symbols, or percentage signs. Now 1.6, that's a double. And here's an important point. If you've already defined a value as a double, like I've done with var myDouble, then I can assign a literal value without decimals to that value, and Swift will automatically consider it to be a double. But be careful, because if I declare a value and initialize it with a 0 and no decimals, then Swift is going to assign the value type as an int. Need to declare a value as a double and initialize it to 0? Just set it equal to 0.0. Same thing with the literal value 4. Since myDouble was already initialized as a double, then if I replace it with the value 4, Swift is going to consider that 4.0. It's still a double. You won't get an error. Really long decimal values, those are okay. Now, if you're working with extremely large or extremely small numbers, you can search online for tutorials on how to deal with large numbers, but doubles will be fine for the vast majority of app ideas. Now 1.6 in quotes, that's a string. Assign that to a variable that's already been declared as a double, and you'll get an error. No currency symbols allowed, and if you have a variable that's been defined as an int like myValue and you try to assign that value to a double, that'll generate an error. So this is important to know. Swift will convert literal values to doubles if you try to assign them to a value that is already a double. So the 0 will be considered 00, 4 will be considered 4.0, but it won't do this for constants or variables that have already been defined as integers. This would generate an error. Now, because Swift has such strict data types, it's often called a type-safe language. It's kind of like the classic children's toy that has blocks of different shapes and holes of different sizes that the shapes fit into. Well, if you think of a string as being, say, a square block, and an int as being, say, an oval block, you can't put a string in an int hole or an int in a string hole. Now in Swift, if you want to combine data or perform calculations, those values need to be of the same data type. You can concatenate a string with a string or perform math on an integer and an integer or a double and a double, but the reason why our code generated the error is because we tried to combine a string with an integer. And in Swift, combining values of different types is not allowed. In fact, you can't even combine numbers of different types. So it's not okay, for example, to multiply an int by a double, which to a non-Swift programmer seems really weird. Now, as a programmer, this requires a little bit of work up front. You've got to think about what type of data you're going to be storing in a value, but in the long run, this is going to make your code far more reliable. The reason why Apple chose to make Swift a type-safe language is because there are a huge portion of errors in other programming languages that are the result of using the wrong value in a type that was expecting something different. So with a type-safe value, you'll have fewer errors in executing code, and if Swift is your first programming language, you'll learn better practices right out of the gate. So now let's head back to the playground and try out some of these techniques, and feel free to try out some of the examples from the earlier slides in your playground. Entering correct and incorrect values for data types can really cement your understanding. For example, we know that numbers can't have currency values or commas, so if we enter a value like developer salary equals $175,000 a year with a $sign and a comma, we see Xcode underlines both the $sign and the comma as problematic, but if we remove those values, everything works fine, and you can even include the underscore as a placeholder too. Cool.
You can option click on developer salary and verify it is indeed an int, and we can also print this out, shift return, and you can see the result in the console.
Now to replicate what we had in our project, it's something like this. Var image number equals 0, var image name equals empty string, and what we tried to do was image name equals, and then the string literal image plus image number. Same error. Cannot convert value of type int to expected argument type string. If we option click on image number, we see, yep, that's an int. Option click on image name, we see, yep, that's a string. Try to combine different types? Swift says no can do. But one way we can fix this is by wrapping the integer in the keyword string in parentheses.
So preface the image number with type name string, capital S.
Types are always upper camel case. Then follow this with the parentheses surrounding the value that we want to convert to a string. Now that doesn't convert image number to a string. Image number is still an int, so if you access it after this, you'll still get an int. But what it does do is it extracts the value inside of image number and converts that to a string for use in this equation. So here we're able to concatenate a string with a 0 in it to the literal string image.
Below this we can say print image name, shift return, and the code works.
So using the type name and parentheses for string conversion is a new method for us. I'm going to comment this out with a command /, but you might already have had an answer for this because we learned another technique that we could use in an earlier lesson. Remember string interpolation? We can write this too. Image name equals the string image.
Then inside the double quotes, I write string interp, which is / open and close parens.
Then in between the parentheses, I can use code completion, bring in image number, shift command enter, the console flashes, and once again we get image 0. Nice. And while we have our playground open, let's work through one more example involving numbers. This shows a common error for new Swift programmers. Say you've got a fitness app and you're trying to convert the miles that you've run to kilometers. And you define miles like this. Let miles run equal 3 and kilometers per mile like this. Let km per mile equal 1.609. Well, if you try to calculate kilometers run with let km run equals miles run times kilometers per mile, you get an error. Try to print out km run, but the error is binary operator star, meaning the multiplication can't be applied to operands of type int and double. Option click on miles run, that's an int. Option click on km per mile, that's a double. But the same technique we learned with strings also works with double. So if I preface miles run with double,
and here's a pro tip for you. If you highlight text in Xcode, then type a character that's part of a pair, like a double quote, curly brace, or parentheses, Xcode will surround your selection in that pair. So here I've selected a variable, I'll type open paren, and Xcode surrounds my selected text in parens. Then I'll enter the type in front of this, capital D double, shift return,
and look at that. We recalculate properly, the miles run, which is 3, is extracted, turn it into a double, 3.0, and the multiplication works. Cool, and you just ran 4.827 kilometers. Now I'll show you a couple more techniques that could have prevented this error. We could have forced the value miles run to be a double. Let me comment out our old let km run line first.
I could have initialized miles run to 3.0 instead.
The 0.0 is a decimal, so Swift implicitly defines this value as a double.
Then if we write this line, let km run equals miles run times km per mile,
we get no errors because if we option click on miles run is now a double. And there's also a method to explicitly declare a value as a type. So if I go back to setting miles run to 3 without the decimal, I could add a colon after the value name, then type, in this case, double. This tells Swift to explicitly declare the value miles run as a double. Regardless of whether it has a decimal or not, Swift will treat this as 3.0, not 3, shift enter, and explicitly declaring the value type works too. Nice! So now let's command accent back over to our project, apply one of the techniques we just learned, and fix that error in our app. So now we know inside of this image string literal, we can just add the string interp, / open and close parens, paste image number in between the parens. I can also delete the print. I don't need that anymore. Moment of truth. Let's click show message. 1, 2, 3, 4, 5, 6, 7, 8, 9. What happens when we click again? And we're back to image 0. Nice. Click away. You're flipping through images. Outstanding work, Swifter.
So now I'll just clean up my code. It's up to you, but I'm going to delete both of these commented out statements here. I don't need them anymore.
Once again, big learning in this lesson. We learned about major data types in Swift, strings, bools, ints, and doubles. We covered Swift's strict type declaration and learned how to implicitly and explicitly declare a type. We learned the ultra-handy option click to show a type's value. We encountered several common errors using Swift types and learned how to prevent them. We covered type conversion, using the type name in parentheses, and using string interpolation. We learned the numeric placeholder, underscore, to make it easier to read large numbers, given that you can't use commas in Swift numbers, and used print for debugging and showing the status of a running program. We saw the debug area and the Xcode project console for the first time. We learned the operator shortcuts plus equal, minus equal, star equal, and slash equal. We work with annotated comments to do, fix me, mark, and we learned how to add divider lines to those comments. We use the Xcode jump bar, and we saw we can use Command F to find. Good gravy, Swifter! You are not only learning Swift and SwiftUI, you are getting lots of useful tips and tricks along the way. Feel good about those skills and buckle up because there's more big learning coming at you. Keep at it!